You open the refrigerator on a Tuesday night and something's off. Not a noise, not a puddle on the floor. The air that comes out isn't cold enough. You reach in and the milk carton is warm to the touch. The freezer's going soft. Ice cream's soup. You unplug it, plug it back in, and it hums for a little while, and then it stops. You move the meat to a cooler with some ice and call somebody in the morning, and by the time the repair truck pulls up your driveway, you already know in your stomach this is not going to be a $40 fix. He's back there for 20 minutes with his gauges and his flashlight, and then he comes around front and writes a number on a pad. Compressor, $800, $900, could run more depending on the unit. And you're standing in your own kitchen doing the math before he finishes the sentence because you remember what that refrigerator cost. The estimate and the replacement price are so close together that the piece of paper in your hand is not really an estimate. It's a goodbye letter. That is not your fault. I need you to hear that right now before I explain a single thing about what went wrong.
I'm Diane. I spent 19 years working in an appliance plant. 9 of those on the line, 10 behind the parts counter.
And I can tell you exactly when that estimate stopped making any kind of sense, because I watched it happen from the other side of the counter. The compressor assemblies we stocked on the shelf used to take 2 hands to get down. Cast iron housing, copper windings inside, heavy enough that you learned fast to bend your knees for that box, or your back told you about it the next morning. Then sometime in the early 2000s, the boxes got lighter. I felt it in my hands before I saw it on any paperwork. The men on the line mentioned it before I did. Same shelf position, same part number family. A different thing inside the box. I want to walk you through what changed inside that part, what it's costing you now, and what you can actually do about it the next time you're standing under the lights in an appliance aisle. And the part that matters most is the one nobody prints on the tag. For roughly 40 years, the compressor in your refrigerator was the same basic piece of equipment. They called it a reciprocating compressor, one speed, on or off. A piston moving back and forth inside a cylinder, cast iron wrapped around it, a copper wound motor, and the whole assembly sealed in its own oil at the bottom of the cabinet. It was overbuilt. That's the word the guys on the line used. And they didn't say it as a compliment exactly, but they didn't say it as a criticism either. They meant the thing had more in it than the job in front of it required. Thicker walls than it needed. Heavier windings than it needed. A motor running at one speed that never got pushed past about 60% of what it could handle. It ran cool because it was loafing, and because it was loafing, it lasted 20 years, 25. Some of them went 30 and were still humming when the family moved out of the house. Then the inverter came in. Variable speed. Instead of on or off, it adjusts. Runs low when the door's been shut all afternoon. Runs higher after you come home with 6 bags of groceries. Quieter. Uses less electricity, smaller, and on paper, in a testing lab under controlled conditions, it is a better compressor. I won't argue that point. But the housing got lighter, the windings got thinner, the clearances got tighter, and the part that used to be the last thing in the machine to quit became one of the first things to go. Let me tell you what a 25-year compressor felt like, because if you lived with a refrigerator long enough, you know part of this already. The old one sat bolted to a plate at the bottom of the cabinet, sealed in oil, and it hummed. You could hear it kick on from the living room. One speed, one pitch, steady as a clock, and if you lived with it long enough, you stopped hearing it entirely until it cycled off and the kitchen went quiet and you noticed the silence. That hum was the sound of a motor that was not working hard. The housing was cast iron, not a plastic molded to look heavy. Cast iron, the kind you feel the cold through if you put your bare hand on it, and the small ones weighed more than a bag of concrete mix. The copper inside was wound tight and heavy, and the whole thing ran cool because it never had to strain. That is what overbuilt means in plain English. Not wasteful, not old-fashioned, just never stressed. When one of those finally failed, and they did fail, nothing runs forever. You were usually looking at a machine that had been in the kitchen 15 or 20 years. Everything else still worked. The seals held, the cabinet was solid, thermostat, door gaskets, shelving, all of it fine. So you called somebody, they came out and put a new compressor in, and you got another 8 or 10 years from that refrigerator. The cost of that one repair spread across the total life of the machine came out to something around $30 or $40 a year. That is arithmetic that works. That is a repair that earns its money back twice over. Now here's what happened to that arithmetic. The inverter compressor does the same job with a fraction of the electricity and almost no noise, and it adjusts itself to the load, and every bit of that is real and measurable. I am not standing here telling you the technology moved backward. The technology moved forward, but the way it moved forward was with variable speeds, tighter clearances, a lighter housing, thinner windings, and electronic speed controls the old design never needed and never had. The motor works harder per cycle at low speed than the old reciprocating motor worked at its only speed. The cast iron went to stamped steel or light alloy, and the entire unit is sealed, so that when it stops working, that is the end of the conversation. Nobody opens a modern compressor. Nobody rebuilds one. You pull it and put a new one in, and that is a job you call somebody for. Because the moment you're into that sealed system, you are past what a homeowner should be touching. The returns started showing up inside of 5 years. I saw that from behind my counter. Refrigerators that were 2 years old, 3 years old, coming back with compressor noise, compressor failure, compressor not cycling right. The warranty handled it, so the customer left thinking it was taken care of. But once that warranty window closed, those same failures kept arriving, and now the number on the estimate was coming out of the customer's pocket. Here is the number that breaks the whole thing open. A compressor replacement on a modern refrigerator runs roughly $800 to $1,200 with the labor. A new refrigerator in the same class costs somewhere around $1,000 to $1,600. When the repair comes in between half and 3/4 the price of a brand new machine, you are not repairing anymore. You are gambling. You are betting that the rest of this refrigerator, built with the same lighter materials and tighter tolerances as the compressor that just failed, holds together long enough to justify what you spent on one part. And when that machine is only 5 or 6 years old, you are betting on a young machine built thin. That bet loses more often than it wins. I wrote up a lot of those estimates in my years behind that counter. I watched people stand there and do the math in their heads, and I watched every single one of them arrive at the same place. Not worth it. And they were right. That math hasn't come out in the customer's favor in years. Everything I just walked you through comes down to one shift. The part that used to be the last component in the machine to give up became one of the first. And it didn't happen because the part got worse at what it does. It got better at what it does. It got worse at lasting. Those are two completely different things, and nobody separates them for you when you're standing in the store reading the tag. What I'm about to tell you next is the part I wish somebody had laid out for me before I bought my last refrigerator. The old compressor had one honest weakness, and it was a real one. It used more electricity. Your power bill ran a few dollars higher every month, and over 20 years of running that adds up to genuine money. I'm not going to stand here and pretend it doesn't. But here is what nobody put on the card next to the efficiency rating. A machine that saves you $8 or $10 a month on your electric bill but lasts 7 years instead of 20 costs you more per year you own it than the old machine that ran your bill up. Add every dollar you saved on power over those 7 years. Now divide the price of the refrigerator by 7. That second number is bigger than the first one every time. The savings went to the electric company for 7 years, and then they went to whoever sold you the next refrigerator and the one after that. The electricity was never the expensive part. The replacement cycle was the expensive part. You just couldn't see it on the sticker because nobody put it there. That is what the title of this video is about. Not that the compressor changed. Everybody who has stood in their kitchen holding an estimate already suspects that. The part nobody tells you is that the feature they sold you as the upgrade, the quieter, more efficient, adjustable speed compressor, is the very feature that cut the life of the machine roughly in half. You paid more for a refrigerator that does more things and lasts fewer years, and the reason it lasts fewer years is the thing they improved. A woman came into my parts department 3 times in 2 years. Same machine each time, different complaint each visit, but the last one was the compressor, and when I gave her the number, she looked at me across the counter and said, "I just bought this thing. She hadn't. She'd bought it 4 years ago, but 4 years with a refrigerator is supposed to feel like you just bought it. That's how short 4 years is in refrigerator time, or at least how short it used to be. So why did this happen? The compressor changed because the standards changed. Efficiency requirements moved up, and the inverter design met them. That part is straightforward, and there is no villain in it. The rules said the machine had to use less power, and this compressor uses less power, and that is simply true. But here is what came with it. The inverter compressor is lighter, less iron, less copper, a smaller footprint inside the cabinet. The part that used to be one of the heaviest, most material-dense components in the machine became one of the lightest, and it started failing sooner, and the only fix is a complete replacement. So the money that used to sit inside a machine for 20 or 25 years now cycles through every 7. The customer buys a refrigerator, it runs for 7 years, the compressor goes, the repair estimate doesn't make sense, the refrigerator goes to the curb, and the customer walks back into the store. That cycle used to take a generation. Now it takes less than a decade. I am not telling you that somebody sat in a room and planned this. I don't know that, and I was not in that room. What I'm saying is, the design that came out on top is the one that's lighter, quieter, more efficient, and shorter-lived, and that didn't require a conspiracy. It just required nobody asking the question out loud. The question being, what happens to the person who bought the machine when this part quits at year 6? Nobody asked that question where the customer could hear the answer. And the part you need to hear is this. You did not buy wrong. You bought what was in front of you, and what was in front of you changed. So here is what you can do, and it's small, and it's free, and you can do it this week. Next time you're near a refrigerator, in a store, at somebody's house, wherever, do 3 things. First, put your hand flat on the side panel and press. If the metal flexes under your palm, that tells you something about what's behind it. Second, stand there and listen. If you cannot hear it running at all, that's the inverter, and now you know what that word means and what it trades away. Third, look at the warranty, and not the warranty on the machine. Look at the warranty on the compressor by itself. A lot of them carry a separate, longer warranty on that one part, and the length of that warranty tells you what even the people who built it expect to fail first. I want to hear from you on this one. What's the oldest refrigerator you've ever owned, and how many years did it run before anything went wrong with it? And when it did finally go, was it the compressor, or was it something else entirely? Next time I want to talk about what happens when the control board goes, because the compressor is not the only part that got lighter. Thanks for being here. I'll see you on the next one.